Okay, good afternoon, everybody. There are still a few people joining, but we'll start very shortly. I'm very pleased to welcome Bob McDonald and Terry Menendez from IBM in San Jose in DFSMS development. I first remember VSAM. I don't know. I don't really want to admit it, but it was in the 70s. and it's interesting to see that there is still serious active development work going on with VSAM to provide facilities that are the sorts of things that people are asking for in a web-enabled environment in the 21st century. Now, I've probably completely lied about the topic of the presentation, so I'd like to hand over to Bob to put me straight. Bob, the floor is yours.
Okay, thank you. Hello, and welcome to Virtual GSE UK. It's morning for me. I think it's afternoon for a lot of you and somewhere maybe in between. My name is Barb McDonald, and I'm the DFSMS Solution Offering Manager. Nigel mentioned we have Terry Menendez on the phone. She's the subject matter expert, so anything we want to know about VSAM, Terry is my go-to person for this. And Nigel actually hit it on the head. VSAM is a technology that has been around for as long as I've been at IBM. I started in VSAM development over 30 years ago at IBM, and it's still going very strong. And this, I'm going to talk today a little bit about some of the new technology that we've been exploring in VSAM, around being able to leverage VSAM and specifically VSAM RLS to provide a NoSQL database on zOS. Before I move to the next one, I'll kind of hit the agenda. We'll take questions through the chat. Terry's on, and we'll try to answer questions via the chat if you guys can get in. We'll kind of hold off there. I won't need the full time for the chart, so we'll do a Q&A at the end, and we'll wrap up with whatever questions folks have in the chat. So please, as I walk through this, if you want to ask questions, put those in the chat, and Terry will try to answer. So I don't have time, and we've got potentially, a lot of different skill levels here today, but I want to start with a brief overview of NoSQL and some of the reasons why you might want to use it when developing your applications. We'll take a minor detour. I don't want to spend a lot of time on this, but because we spend a lot of time talking about BSON and JSON documents, which is really the database type that we're leveraging in VSAM, I want to spend a few minutes just kind of walking you through JSON and BSON. And then we'll describe the capabilities we have today with VSAM DB and the current VSAM APIs that support it. And to wrap up, I want to talk a little bit about future direction and the roadmap with this capability. You'll see as we walk through this, we have, I think, a very solid MVP, but there is room for improvement. And so we'll talk a little bit about where we see this technology going in the future. Okay, to kick it off. The statistics on the left side of the chart, I probably should go out and grab some new ones, but I don't think it should be any surprise to anyone that the amount of growth that we're seeing. And the numbers are probably higher than what I'm showing, but really the main takeaway from this is that last bullet point. It's not about how much data we have, but rather what value we're trying to gain from that data. And as an example, I kind of like to think about, I'm a big Netflix user, and my Netflix is always analyzing my viewing patterns to provide new suggestions and advertise new content. I'm always going, oh, hey, there's a new movie or a new series I might want to binge watch. But it keeps me hooked. It keeps me paying that monthly bill to Netflix. And I'm sure, I'm not the only one out there. And businesses are really taking a look at how am I going to be able to leverage the business value that's behind all this data out here. So, what do we do with all of this data? So really the challenge is trying to manage everything that's coming in. And NoSQL databases were starting to be developed in the late 2000s, really to address some of the limitations around SQL databases, relational databases that application developers were kind of noticing as they tried to drive value from the amount of data that was being generated at the time. And the NoSQL's flexible data schema really enables exceptionally fast access to the data, and many NoSQL databases, offer some high performance indexing, which is really key when you want to start doing analytics on the data. And we're going to talk a little bit more about NoSQL. They really were built to allow the insertion of data without a predefined schema, which is something that if you're really familiar with DB2 and more of a relational database, it's kind of a new idea for you. You know, relational databases are table-based with structured data. You have to have a predefined schema before the data is inserted, and it really doesn't easily allow for changes to the data without having to make application changes as well. You've got to have a DBA in there. NoSQL, on the other hand, really enables rapid, agile application development with less database administrator overhead because the data schema is very flexible. And they're kind of optimized for this new type of business applications that are centered around all this social media posts, photos, videos, email, you name it, anything that's coming in. There are different types of NoSQL databases that are kind of optimized for specific data models. And there's new ones that are coming out there. Every time I'm out and I'm looking online and Googling, you know, NoSQL, you'll see something new that's popping up. But there's a couple of types I'm just going to hit really briefly just to kind of give you an idea of what's out there. The first one is key value. It's really a simple model, as the name says, that has a pair of unique keys and a value associated with it. It's used a lot for web type applications and some of the specific databases that you might have heard of, you know, Redis, Cassandra, DynamoDB, which is one from Amazon. These are all key value types of databases. Column-based databases, they organize data, as the name again suggests, in columns rather than in rows, enabling for faster queries for really large data sets. We see it used a lot for catalogs, fraud detection type of applications. Cassandra is another one that also, in addition to key value, uses column-based. Document databases. This is the one we're really focused on. This is, we think of it as kind of semi-structured data and their descriptions in a document format. So, for example, JSON and BSON can be used, are a document database type, and they can be used for mobile applications and data handling. I'm going to talk, as I said from the agenda, we'll talk a little bit more about the format of JSON and BSON, and it is a type of key value pair, and we'll talk a little bit about what those are. The ones you guys, I'm sure everyone has heard of Mongo and CouchDB are two of the bigger document type of databases. The final one on here is Graph. This is one where the data is organized as nodes and edges. This is much more of a mathematical type of database, and it really kind of drives the connections between the nodes. It's used where map relationships are really important, like with a reservation system application. There's a couple out there. Microsoft Azure CosmoDB is one. The Neo4j is another one that's a graph type. But again, the whole point of NoSQL is this idea of flexibility. So when a developer is looking at their application, they can say, okay, here's kind of what my data looks like, what kind of database is out there. And it really allows for the flexibility, the schema, to do more interactive development. Scalability of NoSQL today on distributed platform relies on what we call horizontal scaling. And if you've heard this term called auto sharding, and this is a concept that automatically spreads the data across the servers, and many databases that do this offer kind of a replication as well. It's different from what we know on Z, where we do more of the horizontal scaling and we're not spreading the data across multiple servers. So we'll talk about how this is, why we think, and especially from a VSAM RLS perspective, we're a little bit better from a zOS perspective if we talk about when we're going to host NoSQL on our platform. Horizontal scaling can lead to, you know, obstacles around transaction consistency. So application developers who are, you know, coding today in the distributed models using the NoSQL databases, they have to code for consistency, which can be a real challenge. And there are some NoSQL databases today, I'm starting to see a little bit more a recognition that they need transaction consistency, and some are looking at how they can provide that. I know I've seen on the Mongo roadmap that they're certainly looking at it, but in general, the application developers are responsible for providing that transaction consistency. And again, we're going to talk a little bit more in the next couple of charts how RLS kind of solves this. So if I'm on zOS today, what do we have from a NoSQL perspective? One of the products that we have out there is IBM Data Virtualization Manager, or DVM. And as the name implies, it leverages virtualization to allow applications access to mainframe systems of record data. And the key thing to remember here is the data remains in its original format, and we allow modern APIs to have virtual access to that data. So it does keep the data on the platform. It avoids having to do, the extract, transform, load, the ETLs, which can be really expensive and time consuming. So data stays on the platform, it stays in its existing format, and we use the modern APIs with the virtualized access to get to that data. One of the things where there are some limitations is that virtualization of the data. It can sometimes be complex, and oftentimes it's a struggle to figure out how do we virtualize that access. Some of you may be familiar with ZCX. It's a container extensions, which we introduced just recently from a zOS perspective. And it does allow you to co-locate NoSQL databases, the latest microservices, analytic frameworks within native zOS through containerization. So it's possible to take an existing NoSQL application, you might have Mongo that you're running on a Linux platform, put it into a container and run it on zOS to gain some of the Z qualities of service like scalability, availability, integrated DR, those kind of things. But one of the things to keep in mind when you're doing this is the licenses. So the licenses that you use to run on Linux also have to be required when you run that applications containerized within ZCX. So that's one of the things we're hearing from clients that say, hey, it's very expensive for me to run, sometimes to run my NoSQL databases on distributed, and now I'm going to have to extend those licenses onto zOS if I'm going to run them in containers. Again, communication between ZCX containers is all, and applications occurs over TCP/IP, so you're not always leveraging all of the strengths of the platform. Containers are certainly something we're seeing a lot of clients use. There's a lot of success with it, and it's certainly one way to go to be able to run NoSQL. But what we're looking at from what we're calling VSAM DB is to provide a new type of data format on Z. So we're actually storing data on zOS as JSON today, as JSON and BSON documents within a VSAM KSDS. So we can provide a document store that can be used with the modern APIs. We'll give application developers, real-time access to data at scale with consistency. That's the real advantage of what RLS and VSAM provide today. So we kind of have this blending of the best of distributed with the NoSQL databases matched with what we think is the best of the Z platform in terms of the scalability and the sysplex-wide data sharing. And we'll talk some more about that. But just wanted to give you a feel for what we have today on the platform if you're trying to use NoSQL today. So we were just talking a little bit about the BSON and the JSON documents, and I'm just going to spend a couple of minutes. This may be, total review for a lot of you, but I always like to touch on this just so you get a sense of, if you're familiar at all with what we do in VSAM, how this is a real natural fit when you're looking at JSON and BSON documents into a VSAM KSDS. And it was relatively easy to take a look at this, and we'll talk a little bit later about what we needed to change. And most of what we changed from a VSAM perspective had to do with relaxing some of the restrictions that we have around VSAM usage today in order for it to be more flexible to handle JSON and BSON. But real quick at a high level, and again, I am not a JSON and BSON expert. If you guys have questions, Terry's a lot more familiar. Put those in the chat, and I've given you links to go and get some additional information. But basically, both JSON and BSON are more of a key value or key value pairs. JSON is based on JavaScript programming language. It has its own text format, but it's very familiar to people who are used to you know, C programming. Similarly for BSON as well, it is a superset of JSON, so it has additional data types that are unavailable in JSON. And I've got an example on the next page to kind of give you an idea. The real advantage to BSON and why you see a lot of BSON usage, Mongo uses BSON as well, it's really designed to be fast. There is an extra length information that they've embedded within within a BSON document string, so that traversal is very much quicker. Sometimes this can add extra information and size to the documents, but we're still finding with the link that the idea behind BSON was really to make this for faster traversal, faster analytics through the data. The other thing from a BSON perspective, integers are stored as 32-bit or 64-bit integers. They don't need to be parsed to and from the text. So there's a couple of advantages around what BSON is doing, just to make it kind of a little step above of what we have with JSON. Here's kind of a very high level example of kind of what this looks like from a document perspective. Within the document, you have this collection of objects. Objects are really a collection of a key and a value pair. The keys are character strings, the values can be strings, numbers, arrays. BSON, like we said, if you go and look at the documentation, it supports up to 20 value types. JSON has just the 5. And you know, we've kind of given a couple of examples here. There's an ID, a key with the value. You can have a name. I think there's an address. There's all sorts of different value pairs. And then internally, the representation within the BSON and the JSON documentation, it's in UTF, it's Unicode. So kind of gave you an example of what one might look like. From a VSAM perspective, the one change that we did have to make is we did have to develop our own parsers to be able to parse through this information as it's being passed, and we're looking at it from a record perspective. So that is brand new code that we did add to support VSAMDB was the parsers. Okay. Now that we kind of hit just a little bit about what does the BSON and the JSON document, you know, look like, and how does it map to a KSDS, and then we'll talk a little bit about some of the APIs that we have today, the changes we made to be able to support it. So again, NoSQL, these key value databases have this kind of varying formats. So it is very, very unstructured from that perspective. And there's no position, there's no formalized position of where these data pairs have to be within each of the objects. From a VSAM perspective, we kind of think of our records as partially structured and partially varying. So you can have a primary key and alternate keys with value, with unstructured data after the key, but the keys have to be in the same location and the length has to be fixed. So from a VSAM perspective, if you change the key location or you change a key length, you may be required to redefine your data structures. So VSAM is semi-structured, and so most of what you'll see on the next chart of what we had to change in order for it to be able to match to JSON and VSAM is really about removing some of the things that make it semi-structured. Before I get to that, I wanted to throw one more thing out here. The other thing that's behind VSAM, and more notably VSAM RLS, as we think about this from a database perspective in general, we think databases should have both what we call the CRUD and the ACID properties. Most databases, CRUD is relatively straightforward. The ACID property is where a lot of the databases start to say, okay, I'm not completely ACID. So transaction consistency is probably one of the biggest obstacles to the adoption of NoSQL. As I was talking about, most of the databases today don't provide for transactional consistency because of the way they scale. That horizontal scaling and spreading the data across multiple servers makes transactions really, really difficult. On the other hand, for decades now, RLS has had 24/7 sysplex data sharing through VSAM RLS. It's one of the strengths of the platform. It's one of the strengths that we have in VSAM RLS is we're really able to leverage the sysplex to be able to provide you with that transaction consistency. In addition, on the platform, we have built-in integration with pervasive encryption. We've got data set level encryption available, which if you go and you start poking around on some of the databases today, the NoSQL databases, security is often a consideration for them with the horizontal scaling. They have some security issues with some of the databases. So you get integrated in with VSAM is the security of the platform. Resiliency, we've got integrated disaster recovery, you've got GDPS, you've got we've also got lifecycle management, HSM, DSS. So all of this to the platform. So to the external programmer, this looks like an database. To the operating and to zOS, this looks like a VSAM data set. So anything you can do today with VSAM, you can do with VSAM DB. So from our perspective, VSAM DB drives less work for the application programmers since they don't have to program for consistency. And I know I sound like a brokered record, I keep saying this, but this is really critical as we've been working and talking to people, the amount of time and the effort that it takes for application developers to have to code for this consistency in more of the distributed model is really a challenge, and they don't want to work with data that's stale. So you're always having to account for this possibility that the data that you're looking at, especially if you're going after, mainframe type of data, it potentially can be stale. So keep the data on the platform, keep the data with your applications, and leverage the strength of the platform by using everything right there on zOS. And that's the value prop that we think we're bringing from the VSAM DB perspective. Okay, so here's kind of the comparison. If you're familiar with VSAM, this may be really interesting for you. If you're not, maybe not so much, but the big difference here is around the restrictions that we really had to lift to make VSAM structured. One of the big ones at the top here, we talk a little bit about the location of the primary key. With VSAM today, the primary key is required, it's fixed location and length. With VSAM DB, it's optional, and there's no fixed location or fixed length. If you do not provide a primary key, we generate one internally for you. So there's some things that we're doing under the covers to make this be look and feel more like VSAM under the covers from a technical perspective. From an alternate index, same thing is true. Alternate indexes had to be fixed location and length, and every record must have the alternate key. With VSAM DB, there's no fixed location, and the records may or may not have that alternate key. One of the things that's a little bit unique, and if we have time and people have questions about it, is the length of the alternate key. We had to restrict it to 252, and we have kind of a unique implementation. I did include a chart in the backup to talk about truncated keys from an alternate index perspective. And you'll see in the APIs that if you do have these really long alternate index keys, what gets returned to you because of how we truncate the keys, you would then have to do some additional parsing of the data. But I did put a chart in the backup for that, and you'll see that as you look at some of the changes that we made to the APIs. The other noticeable change in here is the size of the databases. So again, if you're familiar with VSAM and the way that we structure a VSAM KSDS, we're kind of limited to the size of records by how the data set is structured. So within VSAM, we structure the data set with control intervals, and then we stack a bunch of control intervals together to make a control area. And your record could span CIs, but it could never span a control area. So we were limited to how big a maximum record length could be because of that structure. With VSAM DB, we've removed that restriction, and now you can have these really, really large records, which are more consistent with how people are using NoSQL today. The other thing I forgot to mention when we're talking about alternate indexes, one of the limitations, and this can be a big one for people, is how you add records to an alternate index and also how you delete them. We're very, very structured. There's a very specific order in which you have to do things when you're creating your alternate indexes from a base VSAM perspective. You can't have an empty base before you start creating your alternate index. And when you start to look at, if I want to delete something or I need to change something, everything has to be closed and essentially deallocated before I can do any of that. We removed all of those restrictions from a VSAM DB perspective, so that adding alternate indexes, having these alternate keys, is a lot more dynamic and a lot more flexible. So we were leveraging some of the properties that RLS brings to the table in order to remove some of those restrictions and really make having alternate keys be something that's very straightforward and much less restrictive than what you might have seen from a base VSAM perspective. Okay, we're going to talk a little bit about some of the APIs, the VSAM APIs, the define, the open, get puts, etc., that we modified to support VSAM DB. So again, if you're already familiar with VSAM, this next section will be relatively straightforward. If not, it might be a bit confusing. Again, since my intention is not to provide kind of an overview of the APIs and not go into the in-depth details of every parameter that we modified. There is an example of how to use and invoke VSAM DB, and then I've got a list of publications. And again, one of the things, and I'm going to talk a little bit more about this when we get to the summary section, and it is something we know from an MVP and how we develop this, that's limiting for some people. The APIs today that we're using from a VSAM perspective are very VSAM centric. So if you don't know VSAM, getting access to JSON and BSON today is only available through the VSAM APIs. So this leaves you with assembler and Metal C. And we know that leaves us with a gap for application developers who aren't familiar with this. So we're going to talk a little bit more about this. So as I kind of walk through this, keep this at the back of your mind that, you know, if you are a VSAM developer, you're a VSAM shop, you have VSAM knowledge, this is going to look very straightforward to you. If you're not, we are working to address that, because we do recognize that for a lot of application developers, especially ones not on our platform today or not familiar with the platform, assembler is probably not your programming language of choice. So we'll deal with that towards the end, and I'm going to kind of walk you through what we're looking at, kind of the next steps. So the first one we talked about is define. It's very, very simple, very straightforward. If you want to define one of these new type of databases, there's just a brand new parameter to say, hey, this is a database, tell me if it's BSON or JSON. And then if you want to define a primary key, you can do so, and you can pass it to us in standard how you do today with EBCDIC, or you can pass it to us UTF-8. So we'll take either. If you pass it to us in EBCDIC, we'll convert it to the UTF-8 before we store it out there. Same is true from an alternate index perspective. Again, the big change is around the key. You can pass us the key in EBCDIC, or you can pass it to us from a UTF-8 perspective. And the A and the D that are in there are talking a little bit more about how I mentioned, if you have to truncate the keys from an alternate index perspective. So if you use larger keys than 252 and we have to do some truncation, it's how do you want the multiple records to return to you, ascending or descending order. So there's a little bit of a change there in how you look at the alternate keys. And again, we are expecting, we're using standard BSON, JSON formats. So the parsers that we have developed are based off of the standards that I've listed here, and I know I had those on a different chart as well. So relatively straightforward to define it. As I mentioned, documents can now span not just VSAM records, but they can span control areas, which is ideal for allowing the storing of the really large documents. When you go to open the data set, we're going to require you to open this from an RLS perspective. So if you aren't using RLS today and you want to use this, RLS is the way that you will access the VSAM data through RLS. We will not recognize this through the base VSAM usage. And the options down here, when you define it, this is part of that transactional consistency, depending on how you want to do things from an RLS perspective. One of the changes that we did make, and this is one of the few that we added to both base VSAM and to VSAM DB, is being able to pass 64-bit storage through the RPL. And the RPL, for those of you not familiar, that's the record parameter list. This is how you pass the data to us. And so now that can all be 64-bit storage to allow for the much larger record. But we did put that one, as I said, that is the one enhancement. And Terry may be able to correct me later. There could be others, but I think that was the big one that we did add from a base VSAM perspective as well.
Well, Barb, rather than saying base VSAM, it would be for non-VSAM DB RLS.
Okay. Thanks.
Okay.
I should be careful to clarify. I use base VSAM a lot,
Right.
but non-RLS VSAM.
Right.
Okay, so the next one around opening, and some of this is again familiar if you're used to opening a VSAM data set. The ACB is the standard way that you give us the parameters of how you want to have this the data set opened. We now have a new MacRF parameter that says, hey, I want to open this as a database or not as a database. And we're going to set an indicator that says, hey, if this is on, we're going to bypass the database support, and it is going to look like a non-database VSAM data set. So it would look just like a KSDS in a non-database. We ship this code on 2.3 and above. So the only kind of toleration support that we needed was the ability, we're going to fail RLS opens for databases on a 2.2 system if the ACB, if this bit is not set. Non-RLS will always treat the database as a non-database, so there was no additional toleration, but we had some very minor toleration support for the lower releases. But again, this shipped in 2.3 and above. Again, functions like any kind of data manipulations, whether you're going to try to print it, import it, export it, if you're going to try to copy it, we will access the data set as non-database, as a regular VSAM RLS KSDS, and not as a database for some of the movement functions that you might do with the data set. Okay, now we're looking at record management. So when it actually comes time to putting the records, getting the records back, pointing to the records, very minor changes. Again, we let you pass the larger data areas. You can use 31-bit, but most likely these are going to be really, really large records. So the storage will be above the bar. And again, because of how we're going to parse the input record to find the primary key if one has been defined, or we're going to generate that implicit key. So RPL-ARG, this idea that you're passing the key value to me, is basically ignored, because we're going to parse your input record to find that primary key, because again, location doesn't matter. And then there's a couple of different return codes, new return codes, again, around that concept of the truncated alternate key that I had mentioned. But again, very minor changes from a put perspective. Again, same is true when you go to get to do a point or a get. It only works, a point will only work if implicit keys are not used. So again, if you did not define a primary key and you said, hey, I'm going to use implicit keys, you can't do a point. You can still sequentially read through the file, but the way that we generate implicit keys doesn't really give us a way to locate the record. We don't pass you back what that implicit key is, so you don't know what it is. So you can sequentially read through the files, but you can't actually point to a specific one.
Barb, other than they're allowed to point to the very first record, that FRD
Correct.
value there, or the last record, they can do that.
Which is, you can do that today. But again, if you're using implicit keys and you don't specify a primary key, that concept of being able to go in and grab whatever record that you wanted doesn't exist. Again, as Terry mentioned, the FRD allows you to point to the first record, or actually you could, I didn't put LRD, which is the last record.
Well, so sorry, going back to the implicit key and what Barb was saying about when you define the VSAM DB with no primary key, no key name, we will generate this implicit key for you. We will also return the implicit key back to you on the insert, and then you can use that to retrieve, do a direct retrieve of the document. That's sort of new, Barb. I don't know if you knew that one.
I did not, so thank you. Okay, that's a change. I didn't think we were externalizing the implicit keys. Okay.
Yeah, we do that already, and we may also externalize the derived keys too in the future. But right now you can get your implicit key back.
But then it's up to the user to be able to store all that and keep track of what that implicit is.
Correct.
Okay. So again, really minor changes. These are all documented. We have, I point you to the books later on with the documentation. Again, for anybody who's not a VSAM developer, all of this is going to look kind of gibberish. It's hard to understand if I don't understand assembler or Metal C. This certainly has its limitations. We did provide a couple of samples that shipped in SampLab with this support. So to give you just kind of an idea of how you might use this, how you might define the cluster, again, how you would define the alternate index, do the build index, define the path. Again, if you're familiar with VSAM, this all looks like normal stuff to you. Again, very minor changes have to be made in order to take advantage of this. So not a lot of changes from the API perspective of how to start using this. And again, on the gets, the opens, the gets, the puts, all look very similar. And I think this is actually one of the samples that's in SampLab. It's the one I pulled in here. And you can take a look at that. So not a lot there. So again, if you're familiar with VSAM, and we have a lot of people, I know, as Nigel said when we kicked this off, he remembers using VSAM, from back in the 70s. So we do have a lot of people very familiar with VSAM who are looking, as more and more of our clients are looking to what I'll call, cloud enable, or start thinking about how can we leverage some of the new technology that's out there, and really these flexible database schemas, as we're trying to develop applications and application programs to handle all of this changing amounts of data, what do we have available on the platform? But again, the limitation that we have is assembler and Metal C. I gave you a list here. The support, as I mentioned, was on 2, 3, and above. I listed the APAR number that you needed, and I know in the side-by-side comparisons, there's some changes that we're making with some of the alternate indexes. I know we're always shipping things in the continuous delivery stream, so always have, be on the lookout for new things that we're changing. And I know I listed another APAR of some of the work that we've got around the alternate indexes that are coming out. But one of the more exciting things that we're looking at, and we're working on this, and we understand this is something that we need to do, is we need to be able to provide high level language interfaces and support from a higher level language perspective. So one of the things that we're looking at, and I call them here C-based key value interfaces. We think of it as a C wrapper around this that would enable some of these higher level and more common programming languages over here on the right hand side to be able to get to the NoSQL database right on zOS. Again, like I said, applications, if you're familiar with Metal C and the assembler APIs today, you could get started right away. Everything that you need to get started is available and already out there on 2, 3 on all of our supported releases. Support from native APIs like Kix and COBOL. We're working with both the COBOL and the Kix teams to be able to exploit this. Similar to what we had to do from a VSAM perspective, it's really about removing restrictions. So Kix has restrictions in how it uses VSAM. Same is true from a COBOL perspective. So loosening some of those restrictions are really the only changes that they need to have, because again, under the covers, this is a VSAM KSDS. So before I move on, Terry, I don't know if there's anything else that you wanted to add around some of the new work, some of the enhancements that we are looking at as we move forward with this.
Yeah, I didn't know if do you have another page after this, or was this a?
I have a couple more. I wanted to show we have documentation, and then I have a little shameless plug for you that says, we know that we are working on these interfaces. We know we need to work with the clients who have the use cases, and what do you need to more fully exploit this. So I had that shameless plug with your I gave everybody your email address.
Well, yeah, because in the chat, I mean, we're getting some questions specifically around the the high level language support.
Okay.
So if you have the C-level interfaces, that one chart with the 4 different areas that we're focusing on, maybe they'd like to see that, and they could think about it and see if there's something more missing, or something they'd like to see. So do you have that chart?
I don't have that one up. If you want to, we could pull it up,
well,
and you can
I can just talk to it then, I guess.
What I will do, Terry, before you move, what I'll do, Nigel, is we could put it in to the deck, and I can repost it out there with a picture of what those look like. So I can do that. I can add it in. I'm going to put the giant disclaimer. So I just want everybody to be clear, because this is my job as an OM, and I know Terry's my developer here. So we're moving into this area of work that is not a commitment. This is stuff that we're working on, but it is really important for us to get the sponsor users. We want to do this right. We don't want to put something out here and then find later, hey, if you'd only done this, I could have used it. So I think you'll see this a lot more in a lot of what we're developing from a zOS perspective, that we want to work with you. We want to make sure that when we put stuff out, first and foremost, but this is all brand new. This is stuff that is currently in development. We are working on this. We know this is a deficiency, and we do want to do this. So Terry, I'll let you talk a little bit more. Do you want this picture up still?
Oh yeah, well, yeah, so that's fine. The slide's fine. Yeah, so, as Barb keeps saying, nobody wants to code in assembler, obviously. And so we're working on providing these C-based APIs. And they kind of span 4 different areas. First would be creating and destroying databases. So you would, invoke this API and pass in a couple of parameters to tell us, for example, do you want BSON or JSON? And then under the covers, we would do all the, the necessary catalog calls and so forth to create the database. Then we have open and close kind of APIs. Again, directing us on how you want to, maybe you're establishing a connection to the database and what specific parameters you want to supply for that open. Then we have kind of the CRUD type APIs, reading, updating, inserting, that sort of thing. Also going to the scope of a transaction, the committing, that sort of thing. And then we also are going to have, creating indexes on the fly and quiescing them, that sort of an API. And then we'll have a kind of like a query API where you can get information about the database itself, perhaps the number of records. We're going to, on the CRUD interfaces, we would return the response time, that sort of thing. So you have some performance information. So that's kind of the areas that we're working on with these new APIs and kind of what you might expect. But if anybody has any, suggestions, we're certainly interested in hearing about it.
Terry, were there other questions in the chat? Because this is all I had, and I don't want to forget. I know I was supposed to put this one up about the feedback on the session, and also this one as well from an overall UK, the GSE UK conference charity. So these are the plugs that I wanted to get in before we were done. But were there other questions in the chat that you didn't answer, or you want to go back over some of the questions people were asking?
No, it was kind of more around APIs, so I think we're good.
Okay.
Unless people want to ask, in person, they're welcome to do so.
Okay, so if anybody wants to ask a question rather than typing it in, you should now be able to unmute yourself. And I don't know whether it's good form, but as session chair, I stuck a question in the chat as well about whether there's any intention to provide REST interfaces so that you can sort of do almost direct from HTTP calls.
Terry, did you get that about the
I'm sorry. I was reading something. What was the question?
I'm not sure I can manage to string it together again. The question was, is there an intention to provide REST type interfaces so that it's possible to get access to documents through from basically HTTP calls?
Yeah. So, well, that's kind of the plan. It's sort of funny, but we're kind of working from the bottom up. So we've started with this, kind of server level data store, and then we're providing the C interfaces, and then we're going to work our way up to kind of more, like providing the RESTful interfaces like you're talking about, and, even a full end-to-end kind of web solution. So that's the idea, is we're basically looking for what people want us to do the most so that we can prioritize things. So if that sounds like that's come up a couple times. So that's definitely something we're going to be looking into.
So from a storage management point of view, a VSAM DB is going to be managed by DSS and HSM just the same as an ordinary KSDS. Is that correct?
Yes, the VSAM DB KSDS looks just like any other KSDS from a physical characteristic point of view.
And Terry, that support already shipped with the base stuff. That APAR, I believe, pulls in all of the other pieces that's needed.
Yeah, there's the APAR that Barb referenced is sort of an enabling APAR, and it prereqs all the other necessarily PTFs to put, to bring the whole solution in. But that's all just the new VSAM DB stuff. As far as what Nigel, I think it was Nigel was asking this, the VSAM DB KSDS is physically the same as any other KSDS. So when you're using DSS or HSM, ID cams, you're just basically accessing a regular KSDS from that respect.
Yeah, so any of your management policies, anything else can all, it works on all of those the same as it would today.
Correct.
Yep.
And
Taking some,
another good thing is that whether you're using a primary key or not, we are randomizing the keys in the KSDS ourselves in our internal key. So you can't cause yourself a performance problem by, what traditionally happens with regular VSAM, like if you're building ascending keys and inserting them into KSDS, you're going to be adding to the end of the KSDS, and that's going to cause a performance issue. That can't happen with VSAM DB. We completely randomize our internal key. So that's one good feature I think about it.
Terry, anything else coming in from a chat perspective? Again, you guys have my contact information is in there. Terry's name is in the charts. Really looking to bring in more sponsor users. We are working on some new alpha and beta type programs from a zOS perspective across the board. We've launched it on some of the other initiatives. And I'm definitely looking at exploring that and doing more with that. It's just an easy way to come in. It's an easy way to join it. We're all using the same kind of interfaces. And so stay tuned for that. But if you are interested, please reach out to us. Come and talk to us, and would love to get some sponsor user feedback, understand the use cases, where you might be looking at this. And also, again, if you have requirements around Kix and or COBOL, we are working with those guys, and it's always helpful for us to have direct input from folks that say, hey, I could use this from a COBOL perspective, or I could use this within Kix as well. So we are working with those groups as well. So any kind of feedback or input that you might have, we are really looking for that as we develop this, and we're moving quickly. This stuff is coming out. We are not doing this on a release boundary. These things are coming out, continuous delivery, and we are supporting existing releases in the field. So you don't have to wait to be on a new release of zOS to be able to take advantage of this. So we are trying to make it easier to adopt and be a little bit more agile in how this is getting out to the clients as well.
Okay, are there any further questions from anybody? I haven't seen anything else pop up in the chat. I have put a link into the feedback form in the chat, so you can just click on that, and please do feedback. If there are no further questions, then it only remains for me to thank Barbara and Terry very much indeed for starting at some ridiculous hour to talk to us. So thank you very much. It's a very thought-provoking presentation. It really is quite impressive how there's still so much stuff that is to be done with VSAM. And seeing as you blew me cover, Bob, it was 1975 when I first came across VSAM. So my secret is out.
That's okay. I'm over 31, and Terry's got me beat there too. So I'm not that far off.
Yeah, okay. we never give up in VSAM.
Thank you, Nigel. And again, I will post. I'll add a couple of what Terry was talking about with some of the the new C stuff, I'll put a chart in there in just a few minutes and I'll upload it again. And if people want PowerPoint versions, I know I've been uploading a PDF, but if somebody wants a PowerPoint, more than happy to share that. You can send me an email and I will, I'll send you the PowerPoint. Unless there's a way, Nigel, for us to get those to you and if people want them, but however it works, I'm happy to share PowerPoints as well.
Yeah, the conference website won't let you upload PowerPoints, only PDFs, but yeah, feel free to send me
Reach
the
out to me.
PowerPoints and you know, people can contact me for them. Happy to do that.
Okay, terrific.
Okay, so with that, unless there's any absolute last minute questions, I'll close the conference, close the session so that we can let the room get prepared for the next session. Thank you very much again. Thanks, everybody.